Recommendations for electronic circuits prototyping. Use a 30-watt soldering iron to solder a component in Vero board. Use a soldering iron and sponge with water to clean the tip of the soldering iron. Use a good quality soldering wire to wire up your prototypes. Use a proper wire wrapping wire to wire up your prototypes. Use soldering fume extractor to protect yourself from the fumes of the soldering wire. Use a good quality tin-coated Vero board for your prototyping. We have developed this 7-segment display table to display the digits on multiplex 7-segment display, and here we have written the equivalent hex number to display the digits on multiplex 7-segment display. Now we'll start writing a program to display the digits on multiplex 7-segment display, and time for selection of a digit will be 10 millisecond. And we'll also write the routine to increment the counter in interrupt service routine, and the time to increment the counter will be 1 second. So we'll start writing our program in interrupt service routine. Here in interrupt service routine, we have checked that if the timer 0 interrupt flag bit is equals to 1, so we have reloaded the value in timer 0, that is 217, and we have cleared the timer 0 interrupt flag bit. Now we'll start writing our program, and we'll write. Here we'll check the time, that is to select a digit if it is less than 10 millisecond. So we'll write if the delay, that is SSD delay, SSD underscore DLY, if it is less than or equals to 10, it means that if SSD delay is less than or equals to 10 millisecond, then our program will come into this if statement, and we'll write a program to display the unit digit on multiplex 7-segment display. So first we'll move the data to the port B, and we'll write port B equals to hex, and now we'll select the unit digit of the counter. So we'll write counter %10. It means that we have moved the value of unit digit of the counter to the port B. Now we'll select the anode of the unit digit, and we will write. Here we have 4 variables, that is anode unit, anode 10, anode 100 and anode 1000. So I'll copy these variables from bit assignments, Control C, and we'll paste it here, Control V, equals to 0, and we'll assign the value 1 to all 3 anodes, that is anode 10, anode 100 and anode 1000. So we'll write anode underscore 10 equals to 1, anode underscore 100 equals to 1, and anode underscore 1000 equals to 1. So here we have selected the anode for unit digit, and we have disabled the anode of 10 digit, anode of 100 digit and anode of 1000 digit. From this schematic we can see that anode 0 is connected on port RD0, anode 1 is connected on port RD1, anode 2 is connected on port RD2, and anode 3 is connected on port RD3. And here we can check that anode 0 is connected on the base of this transistor. So if the status of anode 0 will be 0, then this transistor will be forward biased, and the 5 volts will be applied to the anode of the unit digit. So here we have selected AN0 as 0 to display the data on unit place digit. And now we'll increment in SS delay. So we'll write SSD delay plus plus, and this command will increment the SS delay by 1. Now we'll move 10 place digit of the counter to the port B, and we'll select the anode of 10 place digit. Now if the value of SS delay will be greater than 10, then we'll move the 10 place digit of the counter to the port B. So we'll write if SSD delay is greater than 10 and then SSD delay is less than or equals to 20. Then our program will come into this if statement, and here we'll move the 10th place digit of the counter to the port B. So we'll write port B equals to X counter divided by 10, and we'll also adjust the decimal place, that is %10. So here we have divided the counter value by 10 and we have also adjusted the decimal place. Now we'll select the anode of the 10th place digit. So I'll copy these 5 lines from above routine, Ctrl C, and I'll paste it here, Ctrl V, and I'll assign the value 1 to the anode unit. So here I've deselected the anode unit and I'll select the anode 10. So I'll assign the value, that is 0, to the anode 10. So here we have incremented the SSD delay register. So if the SSD delay register is greater than 10 and SSD delay register is less than or equals to 20, then our program will come into this if statement and it will move the 10th place digit of the counter to the port B. Now we'll write another if condition to display the data on 100th place digit. So here I'll copy this if statement, Ctrl C, and I'll paste it here, Ctrl V, and I'll modify this statement to display the data on 100th place digit. So here I'll write if SSD delay register value will be greater than 20 and if it is less than 30, then we'll divide the counter value by 100 and we'll also adjust the decimal place and we'll move the value of 100th place digit to the port B. So here I'll assign the value 1 to the anode 10, that is the anode of 10th place digit, and I'll assign the value 0 to the anode of 100th place digit. And here we have incremented in SSD delay register. Now we'll write another if condition to display the data on 1000th place digit. So I'll copy these lines from this if statement, Ctrl C, and I'll paste it here, Ctrl V, and I'll modify this if statement accordingly. If the value of SSD delay register is greater than 30 and if the value of SSD delay register is less than or equals to 40. So here we'll divide the counter register by 1000 and we'll move this value to the port B. Now we'll select the anode of 1000th place digit. So here I'll assign the value 1 to the anode of 100th place digit, and I'll assign the value 0 to the anode of 1000th place digit. And here we have incremented SSD delay register. Now we'll check if the value of SSD delay register will be greater than 40. So we'll write if SSD delay is greater than 40, then the program will come into this if statement, and here we'll reset the SSD delay register. So we'll write SSD delay register equals to 0. So here we have reinitialized the SSD delay register to the 0 value. Here we have written 5 if statements. In first if statement we are printing the value of unit digit to the 7 segment display, and in second if statement we are printing the value of 10th place digit on 7 segment display. In third if statement we are printing the value of 100th place digit on 7 segment display. In fourth if statement we are printing the value of 1000th place digit on 7 segment display, and on fifth if statement we are resetting the value of SSD delay register to 0. Now we'll add the program to increment the counter value. So here we will write, here we have another delay register, that is counter delay register. So we'll check if the value of this counter delay register will be greater than 1000. So I'll copy this register from here, Ctrl C, and I'll write if Ctrl V. So if this counter delay register is less than or equals to 1000, then our program will come into this if statement. As we know that the interrupt service routine is coming after every 1 millisecond. So if we'll count up to 1000, it means that the delay value will be 1 second. So if the counter delay register is less than or equals to 1000, Then we'll increment this counter delay register and we'll write Control V plus plus. So here we have incremented the counter delay register. Now we'll check if the value of counter delay register is greater than 1000. So we'll write if Control V is greater than 1000, then our program will come into this if statement, and here we'll initialize the counter delay register to 0. So we'll write Control V equals to 0. So here in this if statement we'll check if the value of counter is less than 9999, then we'll increment the counter register. So here we'll write if counter is less than or equals to 9999, so our program will come into this if statement, and here we will increment the counter register. So we'll write counter plus plus. So if the value of counter register is less than 9999, then our program will increment the counter register. Now if the value of counter register will be greater than 9999, then we'll reset the counter. So here we'll write if counter is greater than 9999, then our program will come into this if statement, and here we'll reset the counter. So we'll write counter equals to 0. So here we have written a routine to display the data on multiplex 7 segment display and to increment the counter with a delay of 1 second. Now we have completed our program, and now we'll compile the program and we'll test the result on our prototype. So I'll compile the program. Here we can check our program is compiled successfully and there is no error in the program, and hex file is generated. First I'll connect Picket3 programmer with the prototype, and now I'll run the Picket3 programmer software. I'll go to the file, import hex, and here we have the hex file, that is multiplex 7 segment display project. Hex file successfully imported. OK, write. Now we'll power up the prototype and we'll observe the result of our program. Here we can see the counter is running on multiplex 7 segment display and the LED is blinking with a delay of 500 milliseconds. To observe the result of program more clearly, I'll place a red bezel on this 7 segment display. Here we can observe a flicker in multiplex 7 segment display, and this flicker is due to the duty cycle of the anode selection, because we are selecting anode of a single digit for 10 milliseconds and the off duration for the digit is 30 milliseconds. So we are observing this flicker. In this case, the scanning frequency of this multiplex 7 segment display is 25 Hz. So if we'll increase the scanning frequency up to 50 Hz, then we'll observe that there will be no flicker on this display. Here we have selected a time that is 10 milliseconds for each digit. So we'll reduce this time. Now I'll modify the SSD delay in our program. So I'll replace this value with 5. It means that if the value of SSD delay register is less than or equals to 5, and here I'll also change this value, that is if this delay register is greater than 5 and less than 10, and here we'll check if this value is greater than 10 and if it is less than 15. Here we'll write if SSD delay register is greater than 15 and less than 20, and here we'll replace the maximum limit with 20. Now we'll compile our program and we'll observe the result on prototype. I'll go to the file, import hex. Here I'll load the hex file. OK, write. Now here we can observe that there is no flicker in the display because we have increased the scanning frequency from 25 Hz to 50 Hz, and here we can observe the result of our program. Similarly, we can display any numerical data on this multiplex 7-segment display. We can display the counter value. We can also display the value of temperature, pressure, and any other digital parameter which we would like to display on a multiplex 7-segment display.